Hello, folks. Welcome to this video introduction to IEE 475, Simulating Stochastic Systems. My name is Ted Pavlic. I'm a faculty here at Arizona State University in the School of Computing Informatics and Decision Systems Engineering, as well as the School of Sustainability. And so in this video introduction, I'm going to go over the basics of what you'll learn in this course, as well as the basic course policies as outlined in the syllabus. But you should not view this video lecture as a replacement for the actual syllabus. And so make sure to go onto Canvas for your course section and look up your specific syllabus, because those are kind of the policies that those are the most up-to-date policies that you'll need to follow if we're participating in this course. So the syllabus is posted on Canvas, and you should take a look at it there. While you're on Canvas, you should take a look at some of the other sections that we will use a lot in this course. And so if you look in the module section on Canvas, you can find a lot of course information about your final project, which we'll talk about a little bit here in a bit, different units, which are how we break up the content of this course, and the labs, which allow you to practice some of the things you learn in those units, and give information about the exams for this course, as well as extra resources you can use for your exam preparation. All the assignments are also on there on Canvas. You can view the grades, and again, you can view that syllabus. So super important, the syllabus posted there on Canvas. So how is 475 structured? Well, this is a weekly course structure. So there's two 75-minute lectures and one longer 150-minute laboratory. The laboratory will be led primarily by the TA. In some semesters, depending on personnel requirements, the lab TA may also help grading the assignments that go into the lecture, or maybe in a different grader will be used for those. If you have any correspondence about either the lecture or the lab, then make sure that when you send those emails, in the subject of your emails, you put IEE 475 somewhere in that subject to make it easier for us to spot those emails as you correspond with us. Email is the best way to get in contact, at least with me. If you use Canvas, for example, or one of the other tools we have, like say Slack, it's possible that your message might not be addressed as quickly as it would if you send over email. So I prefer you to send me an email with your concerns or your questions. Make sure that in the subject you have IEE 475 so I can spot it quickly and get back to you within a relatively short turnaround time. It's nice to also have some concise subjects, so that gives me a better idea of how quickly I need to respond or what other people I need to get looped into. So as an example for that, if you have a lab-related email, if you send directly to me, I am almost definitely going to have to get in contact with the TA to confer with what's going on in the lab at that point. So if there are any issues that were brought up, if it's an issue with grading and so on. So it's just best if it's a lab-related issue to email either the TA first or to email the TA with me carbon copied or with the instructor carbon copied. And so there's, either go to the TA first or go to both. For lab related issues, don't go to me first unless I've specifically asked for some special lab, because I or the instructor will have to end up tying in the lab TA anyway before getting back to you. And again, those should be prefixed with that 475 or have an IE 475 in the subject to make it easier for us to spot them. All right, so what is this course? Well, your main objective, if we were to put it into a sentence, is that we want to make sure that you have the ability to identify, model, and analyze stochastic systems using a computer simulation framework. And just defining stochastic systems and simulation is part of what we're here to do. So these terms will become more clear by the end of Unit A, next week, say, and definitely more clear by the end of the semester. So how are we going to do that? Well, the types of things that you're going to do while taking this class is you're going to learn how to incorporate simulation studies into decision-making processes. And so we're going to show you how to use computer-assisted tools in order to help enhance the types of decisions that people do in, say, operations research and industrial engineering. So that's where you're going to be using software programs that will introduce to you in lab and in some cases in lecture in order to build, execute, and collect data from simulation models that are relevant to these different domain areas. You are also going to involve some of the probabilistic modeling you've seen in some of your other courses, and that some of these simulation models require you to build probabilistic models of real world phenomena. And so you'll get a chance to practice that in here. You'll have to use stats that you've probably seen in some of your other course. So the simulation models that you'll generate will generate data with a lot of different variants or sources of variance, as will the real world data that you'll be using in order to try to generate simulations models of those real world systems. And so we have to deal with that variance. And so we have to use statistics, inferential statistics, hypothesis testing, etc. And so with all of this together, then you're going to be building models that help represent real world systems. And so you're going to have an opportunity to use data from real world systems and those models to verify that those models are running properly, validate that they're telling you something interesting about the real world, and calibrate them to make sure that there's fine-tuned to give you as much insight about the real world system as possible. So that's what we're hoping that you will do throughout this period. And by the end of the semester, then the learning outcomes that we will then assess is whether you're able to identify systems appropriate for simulation analysis, whether you're able to build simulations in a selected high-level language. We primarily use the language called ARENA in this class. That whether you're able to, given a simulation model, determine the requirements on the input data that you'll be using to structure how that simulation model works and matches up to the real world, and then how you can take output data from, interpret output data and make statistical inferences about the performance of that model. And then finally, how you take all of that and put it into a report and a presentation to then communicate to a stakeholder who may not know much about simulation at all, results that you have found by using simulation. So that's what we are expecting to get out of that. How do we do that more precisely? Well, we've divided this course up into these units. And so we're going to basically go through an intro. We're going to introduce something called discrete event systems and discrete event systems simulation. That is going to motivate us to be able to talk about other types of simulation models, like agent-based modeling, for example, or system dynamics modeling, which you might see in some other courses. And then once we've motivated why we use discrete event system simulation, that will then allow us to talk about how we fit probabilistic models into these simulation platforms. And in order to do that, we need to talk about things like random number generation. How do you get a computer to generate a random number when computers are inherently deterministic? And so that kind of rounds out everything before the first midterm. So we're sort of motivating modeling, motivating how to use computers to do this modeling, and how to get computers to generate random numbers to plug into our probabilistic models. So that's everything before the midterm. And then we have a midterm to go over all of that stuff. And then I mentioned here that there's a retake opportunity. So you will get an opportunity to have a no-fault retake roughly a week after you take the original midterm. The retake exam will be different than the original exam. So it'll have different questions, but all the questions will be kind of similar length, of similar types of content, and similar difficulty. And so it basically gives you an opportunity to say, well, if you were just getting comfortable with the format of the test, then you'll be able to take another test in a very similar format to better assess things. And then we give you the maximum of the two. And so let's say you don't want to take the first test. Well, that's fine. You could not take the first test and only take the second test, and you'll get the grade that you got on the second test. So I'm not making you take multiple tests. But you can take both tests, or you can take just one, and we take the maximum on those. After the midterm, then, we then start getting into more advanced applications of the simulation models we learned how to start building and executing from before the midterm. So we do something called input modeling. So now that you know how to build a simulation model, how do you tailor it for the actual data sets that you might see in a real world? Well, that involves something called input modeling, which we'll talk a lot. We'll start talking about that by next week. And then once I've gotten all the inputs to my models correct, then how do I verify that the outputs are right? So we're going to talk about verification, making sure you've done all the coding right, and validation, making sure you've actually chosen a model that's a good representation of the real world. So as we're talking about data, then that means that we need to talk about statistics. And so we're going to then review how to do inferences based on data. How do you compare a randomly, data with randomness from a computer, the data with randomness from the real world? How do we actually compare those two together in a rigorous way? And that's where statistics comes into play. And then we round out the semester talking about different ways we can use and improve the way we use our simulations. And so we talk about it, once you've got a working simulation that's validated, then how do we measure things from it? So how do we measure specifically how one simulation runs in absolute terms, or comparing two simulations to sort of see if one strategy is better than another, so in relative terms. And then how do we use our knowledge about statistics to figure out novel ways to run our simulations that prevent us from needing to run so many of them to make these performance evaluations. And then that closes out the semester. So then we'll have a final exam. It's a cumulative exam. It will also have a retake opportunity. Now, how do we do that? The last week of class, you'll take the final exam, and about a week later, during the final exam period, you'll get the opportunity to take the retake. You can skip the first exam and only take the second. You can take the first and skip the second. You can take both. You'll get the maximum of those scores. So it's just like the midterm. Because we need to squish the final exam into a class period, then the final exam will be the length of a midterm, both the final exam and its retake. It still is going to be cumulative. Of course, it's probably going to be more biased towards stuff after the midterm. But of course the stuff after the midterm uses stuff from before the midterm. So you'd expect to see everything from semester on. All right, so that's the basic structure of the lecture material, kind of the main material there. And then there's also this lab stuff. And so everybody's got a 150-minute lab associated, and these labs are meant to complement the lecture material. And so I've got the labs laid out here, and next to them, I've got the lecture unit, or I've got the main sort of class unit that's associated with them. And so there's basically several labs just getting you introduced to modeling and computer-assisted stochastic modeling in general. And then most of the back end of the labs are introducing you to this simulation platform we use called Arena, which is made by Rockwell Automation. It's used by a lot of industrial engineers and operations researchers. And so you will become familiar with that through practice in the laboratory and through your laboratory reports and assignments. And you will ultimately use Arena to build models in your final project. So that final project will also, we've provided some lab time to help you work on that final project. And so that's why there's this these little notched out section here for where you can gather data and then have some open lab time. And then of course, you'll be working on your final project outside of the time we've specifically provided for that, but some of the lab time we have provided to help you with that as well. All right, so what else do you need for this class? Well, the prerequisites, I'm hoping that you come into this class with some background in programming, hopefully some emphasis on, say, logic flow and looping. You know what an if statement is, you know what a while loop is. You're not going to be writing things in Java or C++ or Python. You're going to be using, again, primarily this Arena program. But in this Arena program, it's a very different type of syntax. It's kind of a graphical syntax, but it will require you still to basically understand these flow structures that go into really any programming language. And then some probability statistics. I hope you get it by now. We're going to be using probabilistic models, and we're using data-driven stuff, so you're going to have to do a lot of inference, and so we're going to need those stats. And so probability and stats, both of them together. Probability for the modeling, stats for the data. So, IEE 385, that's a conventional way people get that. Coming into this class, it's sometimes possible to actually kind of take this class concurrently with 385, but it's better to have all that 385 stuff beforehand before you come into this. And we'll do some review in this class, but hopefully you've at least seen a t-test before. You might remember a little bit of what an ANOVA is about. Maybe you know what a linear regression is, or you can at least spot one if I were to show you a graph with a line drawn through it. The text materials, again, we've got kind of theory-based stuff that we go over primarily in the lectures, and the concrete arena-based stuff that we go over in the labs. That's why there's 2 textbooks that are associated with this class. This Discrete Event System Simulation book by Banks, and this simulation book by Kelton et al. And both of these, if you found newer and probably older editions, you would be fine with. There are some homework assignments that it will be very helpful, if not required, for you to have access to the textbook for. And then the laboratory exercises, many of them make use or build upon exercises that start in the textbook. So you do need to have access to these two textbooks while in this course. Now, before every lecture, on Canvas, you'll notice that there are chapters that are highlighted, and it's expected that you'll have perused these chapters, maybe not with a fine-tooth comb, but I'm really expecting that before you go into the lectures and we start interacting in the lectures, you've seen the chapters before. So I've designed the lectures to kind of follow along with a flow in the book, and Banks et al. Is going to tell things a little bit differently than I do, but we're going to be covering the same stuff. And the contrast will be very useful, and you having some exposure to that's going to be helpful when I start asking you questions in class or asking you to confer with each other and so on. So read the chapters associated with the lecture. So lecture A1 is coming up, then you should be reading ahead to chapter 1 before you come into the lecture. All right, now I mentioned that we use Rockwell Automation's Arena simulation software. Okay, so Arena is a discrete event system simulation software package. It runs on Windows, but it can be run within a virtual desktop on a Mac. It is a free download for students. Make sure you download the most up-to-date version, especially if you're using Windows 10. There are some issues with older versions that people try to install on Windows 10. They might seem to work initially, and then they'll stop working when you really start getting into the heavier use of it. So make sure you're downloading the latest version. It is installed in the SIDC labs, including the virtual lab that you can access by remote. So even if you're, say, a Mac user, you can still log into the virtual labs by remote and access Arena on the Windows machine from remote, even if you're running a Mac. If you've never done that before, there's some links here, and there'll be links in the syllabus on Canvas as well that can help you set that up. There are other resources out there related to Arena. So there is an international competition every semester, and you're encouraged to enter if you would like, and that can actually take the place of your final project. So basically, instead of you developing your own kind of custom final project, you use prompts from the Arena student competition, and you submit a final report and a presentation based on that Arena project. So that's something else to take a look at. And then you can look, Arena has provided a video laboratory at arenasimulation.com video library, which gives you a bunch of additional tools for figuring out how to use Arena. And I've put a bunch of things on the Canvas page showing you where to find additional help within Arena. And then I also have posted some video tutorials which I've linked on Canvas for how to do common things within Arena. Okay, other tools that we'll make use of, spreadsheet programs. So initially, before we get into Arena, we're going to be learning about the basics of stochastic simulation modeling, and we will use spreadsheets, at least for a little bit of that. And so having access to, say, Microsoft Excel, Google Sheets, these are all things that ASU students have access to for free as part of being students at ASU, and they should be fine. You might also benefit from access to additional, more sophisticated programs. I'm not going to require you to use these, but if you're comfortable with MATLAB is great for some of the things that we're going to be doing, especially in the earlier parts of the course. Same thing with Mathematica, R. Other stats packages. Towards the end of the class, as you start doing your statistical analysis, although Arena provides you some statistical tools, and so does Excel, of course, if you have access to R or SPSS, SAS, JUMP, then certainly these things you can do even more with some of the data that will come out of your simulation models. So if you're interested in what other things are available as an ASU student, go to myasu.edu and look for My Apps. If you don't see it there, click on the kind of other on your, I think above your student schedule, and you should be able to find the apps available so look for that My Apps there, and you can see all the tools that are available for you as an ASU student. Other course materials beyond that, we will have a lab where we talk about agent-based modeling, and you use NetLogo, a free platform that is loaded onto the laboratory resources, but it's also freely available for you to download and run on any platform, a Unix machine, a Linux machine, a Mac, and a Windows machine. And so, you know, if you're interested in agent-based modeling or individual-based modeling, definitely encourage you to check out NetLogo, and we will talk about NetLogo, at least in some detail, kind of in the first, I don't know, quarter or fifth of the class. And then there are other tools like AnyLogic, VisSim, Simulate, Simio, FlexSim, or PASS. These are all competing products that do either agent-based modeling or discrete event system simulation or system dynamics modeling, or a mixture of those. And so even though you're learning one or two tools in this class, really what I'm hoping you're learning is that you can take what you've learned in those tools and generalize it and then bring it back down into another tool, because you might end up going to working for a company that actually uses FlexSim instead of Arena. Well, hopefully you'll be able to transport your knowledge that you've built up in Arena into FlexSim pretty quickly. But if you want to gain exposure on those, take a look. A lot of them have free downloads that you can try as students, and we can even entertain you altering, say, your final project to use one of these. But you know, get approval from the instructor first. All right. So getting towards the end here, that's what you need. And so how will you be evaluated? So we've structured things here so that there is some attendance. So basically, and I'll go into this in a little more detail towards the end here, we do take attendance. It's 5% of your grade, but there is a drop policy. And so that drop policy is noted at the on Canvas. How is that attendance taken? So at random times throughout a lecture, instructor or me will ask a question based on the lecture, and you'll submit an answer to an online tool, and then you'll end up hitting submit on that online tool at the end of the class, and then your answers to those will end up contributing to your attendance grade for that that day. And so the answers don't have to be correct, but they do have to be coherent with the question that is being asked. Those are individual assessments. And then weekly, there are these interactive Canvas activities, another 5% of your grade, with a pretty hefty drop policy that is described on Canvas. And those allow you to have frequent but low stakes practice at the things that you're learning in lecture. So you can view them as auto-graded homework assignments that help you prepare for midterms, prepare for the final exams, and just generally make sure you're doing the reading and keeping up with the topics and flagging any questions that you might want to bring up in class or with us through other modalities, discussions, etc. Homework assignments. There'll be a couple of homework assignments, a few homework assignments, I would say, throughout the semester. These will be 1 to 2 questions where each question is more in depth than you get in one of those Canvas activities, and those will be manually graded by a grader. And so those allow you to push deeper into, say, the mathematics of what we're doing, etc. Then, of course, I mentioned the midterm closed book, closed notes, but we'll give you some formula sheets as described here and on the syllabus. There is that retake opportunity I already described. Final exam, again, closed book, closed notes, but again, some formula sheets, and again, there's that retake opportunity. There is a final project. This is a group project, which I'll talk about in the next slide here. It's 20% of your grade. And then there are these lab assignments, individual assignments, and then you can ignore this, may only be submitted if present to lab. That's from an old version of this course, and it just didn't get removed from this slide deck. So you can, I can just hit the little annotate button here, and then I can say, all right, let's cross that out so we don't have to worry about that. So don't worry about that right there, but they are individual assignments, that's true. All right, so let's clear that and get rid of this notation. So how does this group project work? So the group project, it's just traditional in a class like this to do a project where you get to practice your simulation. It's traditional to do it in a group because that's how you're going to be doing simulation projects in the future. And that's also much, the logistics work a lot better towards the end of the semester if we have a bunch of these projects. But the deliverables are constrained, and so don't fret. Let's see how things are laid out here. So you're going to form a group in the middle of the semester, and I'll give you more details and deadlines on Canvas. your group is going to form a proposal for a project that's in this form of what's called an input modeling report. And there will be an additional document on Canvas outlining what goes into this report, where you basically say the system that you would like to model and the types of data that you need in order to do that modeling. That's why it's called this input modeling report. The last week of classes, you present a group presentation. You actually upload a video to Canvas, and it archives there. I think you check the constraints on Canvas, but let's say it's a 12-minute video that you upload. And then after you upload your video, then between the middle of that week where you uploaded that video in the last week of class and the end of the week, you watch someone else's video, and then you do a peer evaluation. And this peer evaluation is an individual thing of that other person's video. And then you will then get anonymized peer evaluations from everyone else. And then I will use both the content of your video and the grades from those peer evaluations, aggregate them together to come up with a grade for you. And so, so that's how we do it with a presentation. We do something similar with a report. You with your group will write a 4-page, no longer than 4-page report with a structure that has been outlined online in a separate document. You upload them in the middle of the last week of classes, and then between then and the end of the week, you're assigned randomly someone else's report to read. You read someone else's report, there's a rubric you fill out, and you leave some constructive comments, so then you peer review each one's reports. And so you get to see what other people have written, and it helps you sort of reflect upon technical writing in general. I then use those peer reviews as well as the reports themselves to aggregate them together to come up with a score for the final report for each group. All right, naming conventions. These are kind of important. So it's the cheers down there where everybody knows your name. Homeworks are named after the assignment that that shares like when it was announced. And so like homework B1, that means that that homework, you should be able to do that homework after you have listened or attended lecture B1. So at the point where you've gone through lecture B1, you have all of the knowledge you need to complete that homework. That's the idea there. And then a due date will be given explicitly on Canvas, roughly say a week, maybe a week and a half or so after the homework is assigned. Now these Canvas activities are flipped a little bit differently than that. They are available and they're sort of perpetually available, but then their naming convention is when they're due. So ICAA 2 means this is the online assignment that I want you to do before you go into lecture A2. And so it's meant to help you prepare for the content on lecture A2. So if you're reading ahead, as you should be, then it will help you sort of make sure that you've been doing the right reading. Okay. All right, other course policies. Late policies, excused absence, medical excuses. So homeworks, if you turn them in late, it's a 20% penalty per day late. But then lab reports can't be turned in late. And then you can ignore this. Lab reports will only receive credit. So again, I need to remove that from the presentation, because that is not the case anymore. That was once upon a time the case. And then the final project may not be turned in late. Again, there's this peer review process, so we need to make sure all the final projects are in on time so that there's time for everyone to peer review. So see syllabus policy on excused absences, but the big thing that I'll say here is if you know that you're going to miss a class or miss some requirement, you need to let me know ahead of time as soon as you know. If it is a medical miss, so you missed it because of a medical emergency, there needs to be some verifiable, there needs to be some way to verify that there has been a medical incident and you need to come to me as soon as you are well. So let's say if for some reason you're knocked out for a week, if that's what you needed, then that's what you needed. But then the instant that you're taking classes again, then you're well enough to contact me. And so then you can say, you know, here is what happened, here is my medical excuse, and then we can make accommodations. If it's ahead of time, so you know it's a, say it's a religious observance, or it is a university sanctioned event, you know, sporting events, etc. Those need things you know ahead of time, and then I need to know ahead of those things ahead of time, preferably right at the beginning of the semester. So let's get rid of that notation and clear. All right, grade corrections. If you do get a work returned to you at the instant after it's returned to you, you've got a week to review that and then request a grade change or a grade review. So I don't, if it was returned to you in the second week of classes, I don't want students coming to me in the 15th week of classes saying, I think I could have gotten a half point more or something like that. So I'm happy to do the grade reviews, but they can't all come in at the end of the semester. So you've got a week, review that return stuff, see if there's any corrections that need to be made, let us know, send us a note before that week is out. After that week, then we can't make these adjustments because it just becomes a mess at the end of the semester. And then, by the way, there is ASU's academic integrity policy says that if you request a grade increase or a grade change for things that aren't due with the merits of the course, so let's say you come to me and you say, I need this for my scholarship, or I need this to graduate in a particular time, or I need this to maintain my visa status, etc. None of those have to do with the merit of the course. And I am not allowed to increase your grade unless it has to do with the merit of the course. And likewise, it is a violation of the academic code of conduct of ASU's academic integrity policy to request a grade change for reasons outside of the merits of the course. So if you ask for those things, I am required to report that because it is a violation of the integrity policy. So don't ask for grade changes unless they have to do with a mistake made or a misinterpretation or something like that that relates to the content of the course. I cannot make grade changes for things having to do with things outside the course, and it's actually a violation of academic integrity for you to ask for one, and I have to report. All right, copyrighted material. So paper-based material, video-based material, electronic, etc. It's all copyrighted course material. You can record things for your personal use, but you cannot upload them, you cannot sell them, you cannot give them away to others, at least not without the instructor's permission. And so unless explicit permission is given, do not sell your notes, do not post assignments on websites, do not upload them anywhere. Your own course notes are technically copyrighted for you, the things that you write down, but it is a violation of ASU's academic integrity policy for you to share those without the permission of the instructor. And so even sharing your course notes on a website that aggregates them for other students is a violation of that. And so, so you need to sort of keep all that stuff to yourself. Now, that brings up the question about collaborations. There will be times when students will help other students on things. And I am happy with students from within the class discussing issues related to the content of the class with each other. I think that's great, fantastic. I encourage that, but anything you submit needs to reflect your own personal understanding. So I don't want two students working on the same homework assignment next to each other and sort of sharing the load of that. You know, that would be against the rules. Now, if you want to say like, I don't really understand what a t-test is, and then you talk about t-tests and everything like that, and then the two of you go off on your way, and then you run some simulations and do some t-tests on your own, then that's fine. So you can talk about the course stuff, but you can't talk about specifics, specific answers. So you can't have someone basically telegraph an answer that they put together for someone else to just copy with that. So those types of collaborations are not allowed. And anything called an individual assignment means that you really need to be working on it by yourself. You can ask others for help about broad abstract concepts related to that assignment, but not about the specifics of the assignment itself. Don't ask someone, oh, what answer did you get for that? Is this too high? Is this too low? Those sorts of things. All right, so the last thing here is when we're running things in class, there's a couple of things that will pop up. And so I want you to be prepared for them. And so one of the things is that we'll have question slides like this one. So this is an opportunity for you live in person to then raise your hand or voice a question. If you do not want to voice a question yourself, maybe you just you want it to be anonymous, then I provide this this link down here that this QR code is also ties to, that will take you to a website where it allows you to post an anonymous question and allows you to view the questions posted by others. And then those questions that have already been posted can be voted up in order to sort of say, if a lot of people have that question, we'll sort of move to the top of the list. I will do my best to monitor this during the class. But if I can't monitor it and address these questions during the class, I'll take a look at this group of questions and post answers after the class onto, say, the Canvas discussion boards or an announcement, depending on what type of question it is. The other slide that you'll see are the attendance exercises. And so when I stop for an attendance exercise, you'll see a slide like this. It gives a URL here that you go to fill out the attendance exercise, the QR code that corresponds to that. That will open up a Google form that will have 10 potential answer spots in it. You basically just can keep that up in a tab somewhere in a separate window during the class. And if I ask 2 or 3, let's say, attendance questions, then the first one goes in the first answer slot, the second one goes in the second slot, and so on and so forth. And then eventually at the end of the class, you can hit submit at the bottom of that. And then I will get in one line your ASU ID, because you'll have to log in order to do it, as well as all of your answers. And then I can check them for coherence, and then I can give you your attendance points for that day. You do have to make sure you log into that with your ASU ID though. So if it says you don't have access, you might want to go up to the top right or wherever it is in Google and switch account and make sure that you're not logged in with, say, your Gmail account when you need to be logged into your ASU account. Anything else? Check the syllabus. It's a great resource. That's the thing that's the most up to date. It's on Canvas. Check the syllabus. So with that in mind, the last thing that we have here is this slide, where to go next. So you'll find that there's a Unit 0 on Canvas. You need to complete all of the assignments within that Unit 0, and they're basically just kind of syllabus-related assignments in order to unlock the rest of the course modules. Start reading Chapter 1 in the course textbook to be prepared for our first lecture, Lecture A1. Look for the first ICA assignment for Unit A, which will be due before the corresponding lecture. So I believe, let's say the first ICA assignment is ICA A2, then it'll be due before lecture A2. And so I believe the first assignment is pretty light. And then there's the first lab will be coming up. So look for that on Canvas and be ready to complete it. So if there's any questions, comments, or concerns, feel free to reach out. Let me know, send me an email, prefix with that IEE 475. If it's something that you think applies to a larger group, you can go onto Canvas and say post something in the discussions, and I can try to respond there so that everybody else can see that. Otherwise, I'm looking forward to the course. I think it's a fun course. I think it's a very useful course, and I'm interested in seeing what you think.